Thank you so much, Jacek, for joining us today. So Dr. Jacek Czerwonka is a principal engineering manager at Microsoft, and he leads the Tools for Software Engineers team, focusing on creating solutions for understanding software engineering organizations at Microsoft and also improving engineering processes. And his interests evolve around, well, code review, software testing, and also data-driven decision-making on software projects, as well as engineering process measurement and process improvement and quality assurance. And I've worked for a few years with Jacek, so I'm thrilled that he's joining us today to answer our questions. And as normal, we'll be using the Google Doc for that and also following along in the Zoom chat. Before we go to the questions, I thought I'd ask one. What kind of led you to end up at Microsoft out of, like what encouraged you to work in a big company and to work there in particular?
Yeah, I think that's a simple one because when I tried to join a company, there was really Microsoft and there was everyone else. It was, early 2000s where a lot of the the big industry that now you can see didn't quite exist at the same scale. Now you have many companies of similar complexity and size. And I think this is what was interesting, is the scale and size. And I started working on Windows, which is kind of interesting in operating systems. Low-level code was very interesting to me. So there's only a few places where you could go and do that kind of work. Right. So I ended up here.
Yeah. I didn't realize you started in Windows, so you have quite a large perspective then.
Yeah, 10 years in Windows. Yeah, I'm working on really low-level stuff like file systems and kernel mode drivers, and only after that I started looking at data, which is, you can imagine, big jump.
Yeah, definitely. And I mean, I think you play such an important role at Microsoft, right, in looking at one ES system for all of Microsoft. So we did read your short paper, but before we get into that, you're going to present, I think, a little bit of an overview to get us going. So I'll pass it over to you.
Yeah, thanks. Thanks for having me. I have a few slides, not too many, but I think it will be a nice background and context that hopefully answers some of the questions up front. Yeah, we'll see what's left. But the important bit is that I want to give you some of the thinking process behind what we're doing when we collaborate research and industry. And we are lucky to have a research department inside of the company. Microsoft Research is a fairly strong department, a research facility that is producing a lot of interesting results. It's a separate branch under the company, so they really are reporting up to the CEO, and that gives them a lot of interesting freedom to pursue topics that they feel are interesting. And but of course, what we want is try to absorb it and incorporate it into our tools. So a little bit of context, and this, if you heard people from Microsoft talking, especially around engineering systems, they probably told you some things about the complexity and the size of the company. I'm going to give you a few numbers because this is important as we go forward to see why we're making decisions in a certain way. So the size is one thing that makes it challenging, right? There is 60,000 people in engineering roles. Over 30,000 are developers who actually write code day to day. Our engineering system is mostly Git at this point. Like source control is mostly Git, including some really large repositories, like Windows code fits into a Git repo with some special customizations. But overall, we have thousands of these. This is very different than, for example, a Google or Facebook process, which is very centered around one very, very large repository. We have multiple, we have thousands of these. Just a couple of quick numbers. I was just running some numbers today, 120,000 pull requests created this week. Today we run about 500 million tests. And this is just the central systems. LinkedIn and GitHub and some of our subsidiaries, they have their own systems for reasons. So our main challenge is the scale and diversity. So the way we tackle it, and this is my team's responsibility, is to create common tooling. So we worry about source control. How do we do code review tools, and how do we do planning and tracking, a large scale build, test, deployment, these sorts of things. And we create this default set of tools in a workflow. But then because of how our teams work, especially those very large ones, we have to allow some customizations, what we call at the edge, right? So everybody might be using Git for source control and committing to Git, but they will use a bunch of, at the fringes of the repository, they will be sort of customizing the process. So, code review, I don't have to explain to you how pull requests work. I'll just flash a few screenshots of some tools that we use. So when you see them later, you're familiar at least with the layout. So a lot of our pull requests, code review work happens in GitHub pull request. You're familiar with that, or Azure DevOps pull request experience. It's essentially a website, but we also have special clients for code review. And this is one of those clients. None of these concepts will be unfamiliar. You have a list of changed files, and the changes, reviewers come in. You can add them here. They're recommended reviewers sometimes, required reviewers optional. And then we start the main process, which is commenting. And there are these comment threads that get attached to a piece of code, typically a line or a part of a line. Merge or completion of review, and all of these are sort of standard features by now. When this tool was created, it was a fairly advanced feature to have multiple iterations of a review, so you can string them through the history. So you could add a new version of your change based on comments, and the comments would get carried forward, and you could see the history and respond to feedback as it comes. So when I took over the code review process for Microsoft, as an engineering team knows, what you have to do is to look at the literature, right? Like do a literature review. I'm kidding, that's not what happened. But we wanted to kind of understand what code reviews are for, and spent quite a bit of time looking at some prior work, but also looking at numbers that are very specific to Microsoft, and trying to do surveys and gather some evidence. And so let me just go through a couple of these to set the context. So this is one of the important questions is, what are code reviews for? And what makes code reviews interesting to me is that they are for many things. People claimed often that they are for finding bugs, assuring consistency of code. But it's also, this sort of concept of improving code is definitely there, but there is also this concept of improving the team, sharing knowledge, talking about progress. Often how we talk to each other is just sharing what we did, and it's like a link to a pull request, and that's how the team communicates about its progress to the outside world. One that is not on this list, but it actually is quite important, especially recently for the team I'm leading on right now, is the compliance aspect. Right? There are certain customers who require that we are that we have not just one, but multiple people look at the code before it goes into production. And these are sensitive systems. You might be working for the Department of Health, and there's special governmental regulations around change management, and the code review is the place where all of that can be enforced and happens. One of the interesting things that we wanted to know is that people comment in code reviews, but what are these comments about? So we did this little scouting and looked at several hundred reviews and their comments, tried to just roughly classify them into what is their purpose. So you see the breakdown and the frequency of some of these. Interesting to me is the question of how many of these actually are about finding bugs. And if you take a look at these categories, some of them are pretty obvious. Like if you don't have proper validation, or especially if you have like incorrect functionality, well, that's a bug. If you have thread synchronization issues, resource initialization issues, these are bugs. You count these comments, and it's like about 15% of them are really about what I would consider a straightforward bug. What's interesting about the rest is that documentation, organization of code, like the stuff that's more about how this code will look like for the reviewer and the user later on. Like 5 years from now, if I'm reading this code, am I going to be understanding it, the maintainability aspect? That's really where a lot of these comments are spent in those categories. So that's an interesting thing to know as we are proceeding through this subject. And then we looked at this concept of comment. Actually, I should say comment usefulness, not code review usefulness. All of the code reviews are useful. The comment usefulness was a concept that was pretty simple. We basically asked the author of a code review, the receiver of the comment, did you consider this comment useful? And we had many thousands of these responses collated and then developed a very simple ML model to classify about 1 million of these comments later on. And good thing we could classify them also against this category. And so you can start appreciating what people consider useful. Like, actually, all of the bug related ones are typically useful. The rest can be or is less so. So once we have figured out this usefulness concept, it turns out that about 2/3 of the comments are considered useful to the receiver, and the rest is maybe there's some value in it, but they didn't see it as not as clearly as the other aspects. And so you can take that usefulness and commenting density in general and say, all right, so how does it change with size, for example? Right. So there, I'll give you a couple of graphs that are maybe harder to read, but let me explain. So the x-axis here is the size of the code review in the number of files changed, this is the ratio of useful comments versus everything else. So one of the interesting aspects is that it kind of is steady at about 66%, and then starts going down. Should probably discount all of this because these reviews are kind of infrequent, so you see these jumps. But the usefulness of comments starts going down. It's even more interesting when you look at the number of comments, like the absolute number of comments. We seem to be peaking at about 10 comments per review, no matter the size, and about 6 of them are useful. So, so as size grows, we don't really do the same quality of review, doesn't seem to me, for everything that is a changed file in that. Also, the characteristics of code review or the changes are different for these very large reviews. So that's another little tidbit. We could take that usefulness concept and apply it to a level of experience. So here is what we have plotted as, how many times in your history have you been reviewing, did you review that file? And it starts with, first time you see that file, your comments are not going to be very useful, only about 1/3. This is, large numbers, averages, right? So take it with that in mind. But as you're reviewing that file a second time, third time, that usefulness tends to gravitate towards the mean, and quite fast, in fact. Like if you're reviewing something third time, you're going to have much more substantial feedback for the author. Right. Let me skip this one for a second. This came up in one of the questions in the doc. What's the time it takes to do the reviews? And this is another interesting observation, is that we seem to underestimate the amount of experience and time it takes to do the review, and especially if you look at specific categories. So for example, if someone is saying, okay, code reviews are for finding bugs, what seems to be quite difficult to do. It takes high level of expertise, and in some cases what we call a complete expertise to be able to pinpoint bugs. As that and alternative solutions. And I don't doubt it that this is the toughest job that the code reviewer has, is to really be that specific and that useful in a sense to the author. And as we move through the categories, knowledge transfer, sometimes you don't talk about this specific piece of code, but about a design pattern, right? So we don't have to have expertise in that piece of code to be useful. If you're trying to, go, from the back, if you're trying to avoid build breaks, that's a kind of low bar. Everyone can run a build and some unit tests and say, all right, it's clear, right? So you can pass that really easily without a lot of local expertise. Time. So we talked about time. This is a study by Chris Bird and Peter Rigby, and that looked at Microsoft Teams. These are the last 3, and also some of the competitors that we could get the data from. On each of these distributions, right side is the first contact, as in like the first response to the review. Could be first comment or first sign off, but the completion of the review is on the right side here, right? So I think it's a pretty well established fact at this point that across industry, it takes about a day to run through a review, like a mean case. I can show you some numbers later if you're interested. We can pick a team at Microsoft and look at what they're doing. But that's my experience as well. It takes about a day. One interesting thing is that no matter what you do, there is going to be a long tail, right? And that's 730, 1 year after. Apparently there's a active code reviews or pull requests going on. But that 1 month seems to be also an interesting boundary. That's what we're finding ourselves is, at the 99th percentile, we are talking about a month of completion time. And these are obviously 1 in 100 cases that go that long or less, right? But that's where I think we all agree with the rest of industry. Lots of reasons for that. It's a manual process. It's a heavy human process. It's complicated to do a proper review. So that's another little tidbit for you. So I'm going to run through a few cases of how some of these findings influenced how we deal with tools and processes. I think I have 7 or 8. And as we go, we can sort of discuss what makes them a good case or a beneficial case, or something that it's coming from, perhaps it's coming from research, but industry, at least within our company, we could adopt it. And then maybe some patterns emerge, and we can discuss those as well. So one of the first thing you often do is you look at where are people spending time, because if you know that they're spending time on doing something manually, and you can automate it, that's probably a good way to start. And one of the challenges for large teams especially is finding experts. Now it turns out that we have a lot of data. History of code changes, history of past reviews, and what we can do is look at the content of this new review and say, okay, these 2 people are going to be the most knowledgeable in looking at this newest change. So that's been a standard part of our code reviewing tooling, no matter where we do that, whether we do it in GitHub or in our Azure DevOps more standard tools. Now, I'm probably going to run through them, and then we can talk about criteria. We talked about size of a review. One of the experiments that was interesting, it didn't really amount to a feature, and we can talk about why, but one of the interesting experiments was to try to parse the change and discover if you maybe, as an author, you have bundled a couple of unrelated things, and try to decompose it for you. So this was an attempt to say, look, you actually have 3 different changes going on in here. Some of them are probably a main feature and maybe a bug fix that's kind of unrelated, but you were just touching a file, so you created a new sort of unrelated change in it. And to keep things small, what we could have done is take this information and redirect people's attention, and to just basically make 3 pull requests out of this. This is an interesting concept, and I think it has a lot of value. It is tough to pull off technically, right? You have to know what is related. You have to parse the code, and anytime we have to parse the code, we are faced with the obvious limitation that a lot of teams that are in Microsoft, they are very diverse. They have Some teams work completely in Python because machine learning, or some other teams, a lot of teams are C, C++, C#, TypeScript, JavaScript, Go, right? So now we're in this realm of long tail set of languages that we have to support and understand what is related. So there are sort of mechanical, very technical, cost related factors that make us stop here and say, well, should we do this as a generic feature? If we are talking about things that didn't go so well, we've always been quite proud of our research around change risk and sort of knowing if we can quantify risk of failure. And we've used this concept in many different places. One of the cases where we used it and failed pretty miserably is by exposing this predicted risk to code reviewers and to the change author. It turns out that we really violated the cardinal rule of recommending stuff, which is like we didn't tell people what to do with it, right? We're just saying low risk, medium risk, high risk, very high risk. It's really not clear what to do with that. And then the cost of it is obviously we have to run the infrastructure to train models and predict risks, but also we're just upsetting people. The author of a change will argue, it's like, my change is not high risk, it's just a one-line change, right? And then you have to explain how the decision trees work and then go into that entire business. So from the point of view of benefits, very low. From cost point of view, it just wasn't worth it. And so, that's going to come out as one of the interesting criteria. Is what we're doing directly actionable? And something is going to change because we have created this feature or have taken this research concept and tried to put it in front of people who actually do the software development work day to day. What works super well is nudging. And this is one of these things where the concept is so simple, you'd be surprised why we're not doing this already. We haven't done it for some time. We took the sort of very simple nudge concept. Let me start over. It's very simple to do nudging. Simple nudging. Like after 5 days, I'm going to remind you still have an open code review. But that is not very useful. I mean, you can even take an example of this week, right? If I had 5 days hard-coded over the Thanksgiving break, that is going to upset a lot of people. Like, why are you nudging me? I haven't had the time to be even at work. So we already have to have nudging be a bit more complex, more sophisticated. We have to have the work calendar built in. So what we, in addition, have done here is also looked at pull review sizes and complexity and try to learn from the past. So the nudging here is very dynamic. It is looking at various properties of this review or this pull request, and is trying to match it against this team's history. And it's saying, look, no, the typical review like this in this category took, I don't know, 12 days, let's say. So after about 8 days, we're going to start nudging people if there was no activity, right? That's very different from a pull request that is taking typically 1 day, right? 8 days is completely not useful. The effect of this so far seems to be that in the 99th percentile, we talked about where we are with the long tail. We are probably at around 35 days. We can take a look later and get some raw numbers. For the teams we have worked with on the pilot, and by enabling nudging, we pulled that 99th percentile to 20 days, which is like in code reviewing, that's massive savings. And it's not only the long tail that gets pulled up, but also the median by about half a day, which is again at the size of the company where people are spending at least 20 to 25 minutes on average a day doing code reviewing, times however many tens of thousands of people. That's substantial savings. So even though this is a little bit more complicated, there is training and there's ML involved, and you have to be looking at the neighborhood of those developers and their repositories and the history. because our data comes into one place, it's kind of easy to do, right? So we can train on all repos for the entire company and expose the information in terms of nudges. The next 2 or 3 examples are things that we know from research people were just complaining about. I mean, there's certain dissatisfaction around these things. One of these is, we seem to be commenting about the same thing over and over. And they, for people who've been around that team for a while, comments like that are kind of trivial, but it's also tedious to do. Like you're trying to, you have some tribal knowledge in your head and you want to impart it on the new population and maybe junior developers. And it's so much easier, so much more consistent if we could encode it. And so what happens these days is that we allow the team to put a little config file in the repository that says, if you see a change to this file, just add a little comment, because we know that in the past maybe we forgot about something and now let's not do it again, right? It's purely file-based, right? It doesn't have a lot of smarts around what is this type of change. It's basically, you touch this file, you either edit or you delete, and you should get a little comment saying, well, don't do that because last time it was a failure. So encoding that knowledge then leads to comments like these in one of the pull requests from the bot saying, look, you're changing these files. Some of them have enum types, and if you are doing that, then you have to change your database schema. And here's how you do it, right? And that's, now you have encoded a little bit of tribal knowledge, and it's there for as long as it's useful. ML can be quite useful from the point of view of discovering past patterns and reapplying things that maybe we don't realize as humans that exist in the system. So one of the really interesting successful recommenders is this related files recommender, which all it does is looks at the repo and looks at the commits and says, all right, like the supermarket, you're buying bread and milk at the same time often, right? So if you're buying bread, maybe you're forgetting your milk. This is exactly the same concept. In this case, someone changed the YAML file. And the recommender says, well, what about these tests, right? You should probably be changing these tests because that often happens. Look at all these PRs when that happen. That seems to, it's a fairly simple concept, and thanks to our data layer, we can train on these thousands of repositories sort of in one shot and then expose it to people. And then finally, there is this, well, it's not quite a holy grail, but it is one of those things that we are striving to do, which is, we want to give you something so actionable that you don't have to even put a lot of mental cycles into this. This is obviously going to be only applicable to simpler type fixes, structurally simpler. And in this case, it's this a feature that has been there on GitHub for a while as well. You have a dependency on some component, typically open source, and we discovered that there is a security vulnerability in the version that you're using. We're going to advise you to use a different one, right? And the more advanced version of this is to just to even create a pull request for you, so you can do your reviewing of that automatically generated PR, and you approve it, and then you're done. It's my last slide really, but I'm somewhat in between those cases I described. There was a bit of a discussion about what worked, what didn't, and this is not a full list of criteria. I just sort of put it together for this talk. But as we are going through the decision-making process for, here's an interesting research result or something that seems to be working, and what should we be considering as these criteria for working it into the system? And some of the cases I described clearly violated some of these. The ones that are successful typically have most of them fulfilled, right? They are beneficial and scalable, and you can generalize, and they fit. Yeah, but I think that's it from me as far as me talking. Happy to take questions, however I think you would like to do it.
Great, thank you. I'm just trying to write all this down. It's great. I don't know if you share your slides with us or not, Jacek. This is such a great set of criteria. And I love how you touched actually on a lot of different research ideas that we have kind of come across during the term and talked about how you've, transformed those into tools. I do have a set of questions already, which I shared with you. I'll encourage the class, if you have new questions, to either add them in the Google Doc and I'll come across them as we go, or add them to the Zoom chat. I'm going to be greedy and I'm going to ask the first one. So, you talked about using machine learning quite a few times for these different tools. But I also got the impression that much of the machine learning that you're doing, such as the related files and so on, it's not that sophisticated, right? It seems that the cleverness, if you like, is spotting the need or the opportunity for using it. Would you agree with that? Or are you using some pretty fancy stuff under the hood and you're making it sound easy?
I would agree with that. They're not complicated. They're typically decision trees of certain precision. In fact, we should this entire new topic that we can talk about, which is what's the trade-off between precision and cost effectiveness of that model.
Yeah.
We can talk for an hour about that, but they are simple for a reason. Often what happens is that these more complicated models require much more infrastructure. Like they require some data. So Nudge is a good example, because Nudge in its original research form was considering things like, well, is this person on vacation, right? Should we give them a little bit more time because they're on vacation? Well, the concept on vacation requires us to bring a completely new data source somewhere that we can look at, and you have to look at it consistently. And it's not that simple in a big company. Like people may or may not log their vacation time. Maybe they have an out of office message. What is that enough, right? And there's this infrastructure complexity that this little bit of data introduced. And when you run a model without it, it turns out that you lose like 2% precision. So that's obvious, right? We lose the 2% precision, and that's how it's running. And of course it's a little less precise or accurate, but it is so much more maintainable.
Right. But it seems like a lot of the tools, then you have this kind of implicit model of human behavior, right? Like vacation. I'm sure you look at other things as well. So how do you pull that out? Because you talk a lot about using the data, but how do you kind of pull out the other requirements?
Yeah, generating features for these models is really the tough part, right? There are two tough parts about modeling. There's generating features and there's cleaning data. And then we can put into this much more higher level concepts like fairness, right? Assuring fairness. But it's at the mechanical level that's the generation of features is tough, and we just experiment a lot. I think we try to optimize for how quickly we can give this feature to some set of users, get their feedback, run it for a while in a smaller environment, some smaller scale. Typically, it's not just us we're experimenting on, but typically, we take our team, which is like 200 people, so it's not that small, and we can run a recommender against our own teams, and then expand to at least one or two more that are not in our immediate vicinity. Learn and iterate. It takes time. Like all of these models took really quite a bit of time, even after they were proposed by research and evaluated. Then you start putting it into production and you find all these different corner cases that you have to go ensure that you handle. Yeah.
Great. Thank you. Let me switch to, if we can stop screen sharing, I'm going to put us in gallery mode just so that I can find the students. Thank you so much. Let's start with Tyler's question. And I've been relying on the students for checking whether your questions are answered or not as I manage Zoom. Tyler, would you like to ask your first question? So the first few questions were about the outcomes of doing code review.
Yeah, and to some degree, I think that you answered this question a little bit with the very first couple slides that you talked about, but I'm still interested. So When we talked a little bit about the paper that you initially brought up, the Alberto Bichelli and Christian Bird paper about the outcomes of code review, the authors, I think, indicated in that paper that most commonly the outcome of a code review is an improvement to the code, or that was the most frequently observed outcome. But do you think that that's like the most important outcome? And are there benefits that are less common, but maybe more valuable to code reviews that you think are like more important to focus on?
So that paper, if I remember correctly, said that's what people say is the goal of code review, not necessarily that that's actually what happens.
Yeah, so they said that what people say the goal is to reduce deficiencies, I think. And my question here is about what they found the outcome was, which was some kind of nebulous improvement to the code, but perhaps not a deficiency being fixed.
Yeah, I mean, just from purely the number of things that people report on as pieces of feedback in the review process, it seems like obviously finding a bug is extremely important, and that's how we view the code review. Because like from the point of view of the process, that kind of breakage is pretty catastrophic. Maintainability seems to be in that top one or two. And from the volume of comments, that is the one that we see most often. But maintainability is it's a little like preventative medicine, right? You want to do this because the future generation will thank you, or your future self. But it is not catastrophic enough, right? It doesn't break a build or it doesn't break production. It will still work. And it could be also easier to comment on. And as we go on, people encode some of these maintainability type of feedback into tools, whether it's static analysis or some of the tribal knowledge stuff that they showed. But what makes this whole thing very interesting is that it's very hard to detangle, what are the code reviews for, because they have at least 4 or 5 different purposes. And maybe it really doesn't matter which one is number one, as long as we recognize that sometimes finding bugs is not the only thing. And if you have that in your head, you can start thinking about how you would change your process. So I'll give you an example. One of my favorite cases of people changing the process based on this data is that often teams would want 2 reviewers on a code review or on a pull request, 2 reviewers other than the author. One of the teams, based on this data, said, okay, what if the first reviewer is really what's necessary to push this code into your trunk branch, into main. Second reviewer is still necessary before we deploy, but you don't have to wait as the author on 2 before you fully push this code and merge it. Now that's interesting because what happens with first and second reviewer, they are not independent reviewers. Right? The second reviewer is often pulling, so taking a different approach than the first one. And it turns out that straightforward bugs are typically found by the first reviewer, and the combination of the first and the second gives you the sort of the maintainability boost. Right, so changing that process around it definitely unlocks speed. Right, you can take your pull requests into the main code base faster.
That's a great example. Thanks.
Yeah, great. Thanks to Tyler for asking that. Next, we have a little bit about outcome as well, but digging into a little bit more about security, which you touched on a little bit. I'll invite Nimi to ask this question.
Thanks, Peggy. I wanted to know, like, what are the practices for monitoring privacy and security violations during code reviews in Microsoft? Or is there any other process for security check sort of checkings?
Yeah, so security, privacy is very similar, but also accessibility. They are all important as these properties of good software. They are much more cross-cutting than than that, right? A code review is a place where a lot of feedback can be given, and the eyes of the team are on the change, which is kind of convenient. And it's a place where both feedback from machines, like static analysis tools, or build or test comes in, and also feedback from people, which is kind of unusual, right? You have those two types of entities really telling you something about the change. So code review has a huge role in sort of ensuring that security is taken into account, but it's one of n things that happens. And there are these rings of security and privacy and accessibility assurance that some of it happens early on, even in your development environment. You could run your static analysis tools on your local machine as you develop, right? That's one way to do it. Local build typically takes care of it. Then you proceed to do a code review. That's another check. Maybe there are tools that are a bit more complicated. You cannot run all of them on your local machine or they will take too long. So a code review is a place where that feedback could come, because we have this massive cloud that can run processes behind the scenes. And then there is the test and deployment process. And there is another layer there. So no matter which of these you talk about, accessibility, security, privacy, yeah, you'll find code review to be used sort of as a gate, like a very convenient gate. And we try to put a lot of stuff in there, but there is also a challenge of try not to do too much of it. We don't want to necessarily do things that are unusual around code review or unexpected. Yeah.
Yeah.
Tell me if I'm not answering your question.
I think, yeah, it did answer your question. I think, didn't it, Nimi touched on it? Yeah, I mean, we've talked actually quite a bit about code review in this course, almost a little bit accidentally, I would say even. You know, it seems like it's such an important part of the process, right? That it's driving so much. Yeah.
It is, and it's interesting from we touched upon some of these aspects, but there is something nice about exposing a larger group of people to a change. Like it's like paper review, same thing, right?
Yeah.
It's exactly the same dynamic and exactly the same cost and benefits at the high level.
Yeah. Yeah. Great. Okay. Thanks, Nimi. Dylan, did you want to jump in?
Yeah, for sure. So I had a question about one of the outcomes of the paper. It was about like 15% of comments provided by reviewers were about defects. I was wondering if this was a reasonably reflective of the actual number of defects in the code, or if it was because other things, like maintainability issues were just easier to point out than actually finding the bugs.
Yeah, it's very hard to detangle, but I don't know if it matters. In a sense, we're trying to look at the efficiency and the way the process works, right? And we're not trying to find all the bugs through a code review. That would be fantastic, but that's not what happens. Like by the time you're in a code review, you already likely have created and run all the relevant unit tests. So you found a bunch of bugs. You probably even have run a bunch of integration tests and you found a bunch of bugs. And hopefully code review, you're looking at code review as the place where bugs are found. That would be quite unfortunate if a team did that. And obviously there are certain bugs that maybe you don't have test coverage for, right? Especially these more complicated synchronization bugs and concurrency issues that you have to hit a certain interleaving to really expose yourself to it in testing. But an experienced reviewer can take a look and tell you, or a security bug, right? If your test is unlikely to find you a buffer overflow so easily, but an experienced reviewer might, or even some static analysis tools could do this as well. Yeah, I'm not sure where I was going with this, honestly.
Late on a Friday.
Maybe.
I'll pop Dan. Thank you, Dylan, for that. I'll pop to the next section and ask Jordan. We'll ask a couple of questions about challenges with doing code reviews. Jordan, do you want to pop in?
Sure. Yeah. So I think in the paper you mentioned that code reviews, it forces the reviewer to switch context away from their current work. And I was wondering if you've looked at the impact of the attentional disruptions on individuals who do code reviews and how it affects their own work.
Nothing that I can share with any sort of level of confidence. I think Microsoft Research and obviously people in academia have done a bunch of work there. I'm sure there are studies on attention, and the concept of flow was, this popular term that we try to fold into our workflows somehow. It's been quite popular as a quick way to describe, don't distract me because I'm doing deep deep work of certain complexity and value. No, we haven't done anything that's specific that we can share with any level of confidence.
Oh, okay, thanks, Jordan. We had a bunch of questions about sort of code reviews compared with alternatives. He was wondering about, can we skip code reviews and use other tools? You touched on this a little bit, like static analysis tools. And others were asking, if we had more sophisticated AI systems during integration stages, how, have you thought about that, like replacing code reviews with other tools? Or even, compared with older code inspections, for example?
Yeah, so I was looking at the distribution of time, code review completion, and I just took the last 300 days, almost a year. Oh, you know what? I'll do that.
You also mentioned you might show some of your dashboards. I don't know if you were planning to do that or if you can't.
Yeah, so I'm showing you all the secrets now. You can see it, right?
I'm recording. Should I stop recording?
Yeah, it's okay. So let's look at the distribution. So I pulled the 10th percentile, 50th, 80th and 99th completion time. And please take it with a grain of salt. This is like, last 300 days. There is so many problems with just reading this data raw. If you zoom into any particular team, the data will be a little bit different. But here's maybe part of the answer that you were asking for, Peggy, which is, this is the 10th percentile. It takes 6 seconds to complete a review at the 10th percentile. Is that surprising? It's also surprising. Yeah, 1 in 10 gets completed in about 5 to 6 seconds. So what that says is that they are auto-approved. I mean, there is no way that a human is in the loop for these.
Right.
And so yes, there's definitely this concept of there's a portion of reviews or pull requests which go in with automated checks that run, and they're pretty cheap, probably static analysis type on source code or on config changes, and they are approved and they go in. Right, so that's one way to look at it. You also asked about, can we replace code reviews with something else? The way we use code reviews is almost like a canvas for talking to people. It's just a convenient place in the workflow where there's multiple, not just the author, but at least 1 or 2 of the author's friends, teammates, who are looking at the same stuff, and then we as in the system, the machines that run a bunch of processes, we can give them some feedback. But also then the involved people can give feedback to the author. So I'm hard pressed to come up with an alternative where we don't have this anymore. Like we don't have a place where we can share feedback from people and from machines in one convenient place where it's all collected and then preserved, and there is a track record, and you can see the changes happening over time and how people evolved their commits, their thinking. Now, when I started at Microsoft, we were doing inspections for some type of changes. I feel like Windows was sort of ahead of its time because we did code reviews since forever, since I started, like probably early 2000s, where it started, it was already there. We didn't have a lot of good tools, so it was done by sharing your change, packaged by some script through an email, and then you would respond with comments through an email. It was pretty awful, right? But you could see the process was there, and people really took it seriously. For some types of changes that we would consider design or architectural changes, we would do an inspection, and that was quite useful. It was just very hard to do. It's just a synchronous process. You have to get people in the same room, right, and look at code, and it's just by nature of our work being much more distributed and just much more fast paced. We have to do it as asynchronously, and code review or pull requests to me seems like that's the model that is there, partially because of their practical coordination between people reasons.
Mm-hmm, mm-hmm. Great, thank you for that insight. I think we just have I don't know how you feel time-wise. We have a couple of other questions. Derek, yeah, are you okay?
Yeah.
Derek, did you want to jump in with your question?
Yeah, I'll try to shorten this one up. Also, Dr. German, feel free to tag in on this. He was talking about it earlier.
Oh, okay.
So often from what I'm hearing is that you do your code review and then you send it off to the build system to go do all of its testing. Since they usually take a while, should we go and just test on that system first? Where I was working, we did that, which was apparently unusual. We just send off all of our changes, let the build system figure out if there's any issues, and then we'd send it to review, because that took about half an hour and we have a build farm, so whatever.
Yeah.
Should it be done more often? Because most, I think, are done review and then send it off and maybe it crashes.
Yeah, so I think the general principle is get as much feedback in front of that change author as early as possible. Like we coined this phrase "shift left." You know, shift all of your sort of validation processes as much as possible to the left, to the IDE even. Right, your development environment should be putting squiggly lines like IntelliSense, saying that you will get a build break because we ran a build in the background and it broke on this line, right? And you didn't even initiate any action. So that's the principle. But then you have to take the reality of how systems work, right? How long that build will take, right? How many tests you have to run, and which of them require fairly complicated infrastructure to configure and set up. So depending on which team you're on, you might have a much easier time shifting a lot of things to the left, and some teams will just have to batch things up and send them to the same process a little later. And that later can be as late as code review or pull request itself. This is very, very typical for teams to do. No matter what you did on your local desktop, you could have run a build, you could have run all the tests. This is normal. Once you have raised a pull request, typically there is a task that will take it to the build farm and run it against the latest mainline code. And if it fails, it tells you. If the tests fail, it also tells you. If you have done something that maybe during build, you also have static analysis tools running, those will throw a bunch of errors, and then comments will show up. So that's the typical process. Microsoft is complicated, so I wouldn't be surprised if some teams don't have that. They have to do it later because of how complicated some of their testing setups are. Yeah, but do it as early as you can. If it's cheap, just do it, right?
Great. Thanks, Derek. All right. Well, very last question. Alessandra has quite an interesting question that I'm quite curious to know. This is what your answer is going to be to this one. Alessandra.
Yeah, hello. During our classes, we had a chance to hear about different research initiatives at Microsoft. And as you have just shared with us, if more complex models are in use, it may require additional infrastructure. It comes to a cost. So from a practical perspective, I'd like to understand if you have evaluated the performance costs of your systems and infrastructure while introducing these new features or transactions to record and keep this additional data. And how is negotiated with the product owners and managers while you are adding something that is for research purpose? Of course, we know that there may be a benefit, but there are other items in their backlog. So how you do that?
Yeah, that's a good one. It's an important concept to keep in mind. That I would maybe first differentiate between like infrastructure costs and human costs. Because if someone comes to us, to our team, saying, look, we're going to require 1,000 machines for like a day to run some modeling, but it's going to create this benefit, that is a cost that is not negligible, but in the grand scheme of things, the infrastructure costs are already pretty substantial for us. We're adding not a lot to the whole bill, and experimentation is useful, right? If it really turns out to be beneficial, then let's run an experiment on a small scale, let's prove it. And so we're always open to spending money on infrastructure. I am much more concerned about spending human capital. It can have multiple forms, right? Spending time by our team on this takes it away from something else. Human attention in general, like if we start doing something that potentially distracts or adds to the workload of every engineer, that would be a pretty disastrous proposition. And you can easily quantify it at the lower bound, at least. Take an average salary times how many people and how many minutes you're going to take off of their day, and you have to be able to say, look, this is worth it at some level. So, and that's just the lower bound, because really what we are the alternative, what those people will be spending time on otherwise, is probably much more important to quantify as well. The sort of the costs of not doing something else. So I think we have in our heads by now a bit of a decision tree that takes a research idea and decomposes it into, here's all the costs that we will potentially incur. Here's all the benefits. That's what we think we'll get. Can we prove that this is all going to work? The cost benefit is what is advertised. And if we're okay with this equation, the benefit far outweighs the total cost, including cost of maintaining this new system or a new model and refreshing it and responding to people's feedback, which is never cost is zero. So then we do it, right? And it's a rough math, and sometimes we run it for a while in small scale. It works and it checks out. You put it out there and in front of 50,000 people, and it stops making sense, becomes sort of like cost is kind of equal to benefit, and we pull it out. Like this change risk prediction I showed you, that little box that said, predicted risk of change low. That box is gone. It's been gone for a while because it really was the cost and benefit equation wasn't working out, right? So experiment, take it out, and then obviously try to monitor where we spend most time and money on ongoing maintenance of these things.
Great, thanks, Alessandra. That was a great question, I think, to end our discussion with. Thank you so much, Jacek, for taking the time on your holiday weekend to join us today. Yeah, I don't know if you have any closing remarks you want to make before we close it, but
well, other than thanks for having me, I always like talking about these things. Code review is close to my heart. It's not really my job anymore to look over code reviews. I'm much more concerned with security and compliance these days, and that kind of part of the system. But code review is such a rich and an interesting piece, and that often it just is a good starting point to some other discussions. You can sort of spend a lot of time on just code review and its dynamics.
yeah.
So yeah, thanks for having me. Reach out if you have any further questions. I'll send you my slides. And yeah,
Perfect.
have a good weekend.